Numbers have existed pretty much forever, right? Not quite. In fact, the digits 1 through 9 as we know them were created by Indian mathematicians somewhere in between the 1st and 4th centuries AD. We call these numbers integers. And why did we adopt this system of characters? The answer is the same as most answers in mathematics, because it simply makes sense to write them this way. We want to write 1 to 10. Let's do that. 1. Now why do we write 1 in that fashion? The character 1 has one little angle. 2 has two little angles. And so on and so forth. The numbers are shaped such that they have a countable number of little angles. And even before there was a counting system, could you count without numbers? In a way, you could. Pretend you're a shepherd. You need a way to keep track of your sheep. So you throw a bunch of stones in a bowl, it doesn't matter how many, and you remove one when a sheep leaves the yard, and return one to the bowl when a sheep returns. You don't need to know the total number of sheep. All you need to know is that if you have no stones out of the bowl, then you have all of your sheep accounted for, safe and sound. So at this point, we've talked about the baby numbers and sheep. For a long time, people were satisfied with this. But what about when we have half of something, or a quarter, or an eighth? We need a way to represent these numbers which are somewhere in between 0 and 1. Today we call them fractions, numbers that can be represented as some number p over q, where p and q are integers. Fractions can also be called rational numbers. So we can now represent pieces of quantities. We can now do things like make change and divide food amongst a group of people. So what's next? We find that some fractions don't give us numbers that are quite nice to work with. For example, say I want to find out how the area of a circle relates to the radius. These two measurements are connected by a number we call pi. Pi is what we call in the math world an irrational number. It can't be represented as some number p over q, although a very close approximation is 22 over 7, sometimes called the Chinese approximation. However closely we can approximate, we will likely never find a fraction which exactly represents pi. For a long time, civilization was again satisfied. We simply didn't need any other kinds of numbers. Back to the basics now. I want to take the square root of 4. Immediately you might respond with 2. However, that isn't quite right. The answer is actually 2 and negative 2, because negative 2 times negative 2 is also 4. Now what if I want to take the square root of negative 4? We want to take the square root of a negative number here. Let's break up negative 4 into the square root of 4 and the square root of negative 1. The square root of 4 is plus or minus 2, but what's the square root of negative 1? If you're stumped, don't feel bad. The actual significance and tangible meaning for this number isn't understood until hundreds of years of mathematical inquiry. René Descartes, one of the most famous natural philosophers, today we would just call him a mathematician and scientist, mentions the idea of complex numbers in a famous paper, but he hates them. Descartes refers to them as imaginary in a derogatory fashion. It isn't until Leonhard Euler and Carl Friedrich Gauss come along some 100 years later that imaginary numbers are truly appreciated because of their newfound applications in mathematics and physics. But yet again, imaginary numbers are just a way to represent quantities, just like integers, rational, and irrational numbers before them. We can say at this point in the history of mathematics that any number we can conceive of can be represented as some number z equals a plus ib, where a is the real part and ib the imaginary part. Without the work of these two men, we wouldn't have the slightest clue how to make things such as simple AC circuits work. Goodbye radio, goodbye computer, goodbye iPhone. And so we've reached the present day. We are again satisfied with the numbers we have. Why? Because they're good enough for physicists and mathematicians, and a new kind of number just isn't needed yet. Maybe sometime soon, a grumpy old European man will discover a new way to represent a number, but until then, we are satisfied. Thanks for watching, and please like, comment, and subscribe for more physics and math content.